Presented by Caltech.
One fateful day in middle school, I got my first test back in geometry. I got a C. This was nothing short of devastating. A C! I had never made so many mistakes before in one sitting. But the real pain was going to be showing this grade to my dad. You see, I grew up in an environment where making mistakes was unacceptable. Whether I made a mistake in the classroom or on the soccer field or even in routine conversation, I would never hear the end of it. Even the smallest errors were met with animosity. So I was petrified by the prospect of failure. And I would do anything to avoid making mistakes. As soon as I got that test back, I was practically dizzy with apprehension at the thought of what might be waiting for me at home after a long school day. I certainly consider myself a measure twice, cut once type of person. As an engineer, when the stakes are high, my goal is to minimize the chances of my systems failing. A wrong calculation or a prediction can result in lost money, a misdiagnosis, a car crash, or even an explosion. And when mistakes spell doom, that really dictates the way you approach problems. Let's think about a really challenging example, like launching a rocket into space, or better yet, getting a rocket stage to land back here on Earth. That's something I got to be a part of as a bright-eyed intern at SpaceX. I mean, think about how hard that is. I love the analogy that I've read in some of the press releases regarding SpaceX's recent landings. Landing a rocket is like launching a pencil over the Empire State Building, having it reverse, come back down, and land on a shoebox on the ground in a windstorm. With tasks like these, though, there's only one way to get them right, and a million ways they can go wrong. So how do we approach a problem like that at SpaceX? Well, first, you model and test every single nut and bolt that goes on that rocket. You pin down mathematically exactly what's going to happen at every stage of launch within tiny margins of error. And amazingly, you achieve that 1 in a million success. I just never got to experience one. Remember how I mentioned explosions? I got to sit in the front row for the aftermath of an explosion my first week at SpaceX. I was in the crowd cheering on Mission Control and the rocket that was destined for the International Space Station would suddenly, poof, it burst into a ball of smoke and flames. That silenced us instantly. Silenced operation, too. No new launches until we figured out what went wrong and why. People feared for their jobs. People feared for the company, let alone the astronauts that still needed their supplies. Needless to say, we didn't take that failure too lightly. Well, I moved on from building rockets at SpaceX and moved on to another task in my academic studies, getting a computer program to recognize a human face in a photograph. Suddenly, I went from a task that took the world's greatest engineers to accomplish to one of the easiest problems. This is something babies can do. So I know how to solve the world's toughest problem. I can use that same measure twice, cut once approach to get this program to recognize a face, right? Well, let's think about it. First, you model the nuts and bolts. How would you define a face mathematically? I might define its shape and all the variations. Then I have to define the shape of the eyes, the mouth, the nose. And then I have to define all the possible colors for eyes and skin, not to mention the relative sizes and distances between everything. After a lot of work, I might come up with a long list of properties of a face. So first, I hardwire those into my program, and then it's time to test. In this case, we're testing accuracy. So if I show 100 pictures of faces, in how many of those will my computer program correctly detect and locate the face? As it turns out, with this approach, I can't get this thing to do any better than if I just closed my eyes and randomly picked a spot on the photograph. There's just too much variation. I run into problems with shadows, lighting changes, camera resolution. My program finds faces in the trees and in the sky. Places that look nothing like the face in the middle of the frickin' picture. But we figured out. So regardless of this variation, I run into a couple other problems. So no matter how hard, or no matter how exhaustive my definition is for a face, I just can't seem to pin this thing down mathematically. My rocket building approach just isn't working. And that's when I go back to my horrible geometry test. That test had me sick the entire school day. It really did. But I finally got back home. I walked up to my dad, and I handed him the test. I said, "Dad, I got a C." A C. Well, it's about time. Thank goodness. He jumped up, he started dancing. He's like, "You got a C." He was celebrating my failure. To be clear, the crushing, error-averse environment of my upbringing was entirely self-imposed. My parents always stressed to me that making mistakes was an important part of the learning process. Of course, making mistakes or learning from your mistakes isn't everything. We all know how to do that. SpaceX made absolutely sure that it learned from its mistakes. But treating every failure like an explosion doesn't always work. And therein lies the answer to our face recognition problem. To solve this problem, we need to borrow an approach from one of my favorite fields, statistical machine learning. We're not afraid of making mistakes anymore. Oh no, far from it. In machine learning, we happily and even deliberately make mistakes because that's how you learn. So you let your computer program be stupid at the very beginning. That's okay. Each time it tries to recognize a face in the photograph, you let it know whether it was right or wrong, and based on your feedback, it just slightly tweaks its decision process. And sure enough, after a few thousand photographs, the program becomes pretty darn good. Now, I've used face recognition as a particularly accessible example, one that people have actually had solved for a while now. But the applications don't stop there. You see, with this change in mindset, we can begin to make progress on any easy problem where we can clearly see a pattern, but we just can't pin it down mathematically. Of course, there's a trade-off. To learn exclusively from mistakes, you need a lot of chances to fail. These come in the form of data, and that's why data has become so important in this day and age. So remember, failure, it's not just okay, it's a necessity. And when we celebrate it, we start to be able to solve the world's easiest problems. Thank you.